Hello friends, today we're going to be learning about pacemakers. My name is Hudson Summer and thank you for coming to my ECE 331 presentation. Alright, an application of pacemakers. They were developed for clinical use in 1960, used to regulate heartbeats for people with irregular heartbeats. Part of the issue, people have heart attacks, people get older in age, they have issues with blood clotting, their heart can't pump blood at the rate that their body needs. They get irregular heartbeats. This needs to be regulated. Designed as a long-term assistance device and then deliver small electrical pulses into the heart in order to influence heart rate. The way I think of it is sort of the inverse of the defibrillator. So defibrillator, one-time use, a lot of power. Goal is to shock the heart back into rhythm. A pacemaker, long-term use, low voltage, goal is to keep that heart in rhythm. So the electronics behind it, there's a battery, a microprocessor to dictate actions, a pulse generator circuit consisting of capacitors, switches, a transistor, small wires which are attached through the veins into the heart, and a telemetry circuit and a sensing circuit. So you can see here in the diagram, it sort of shows how a pacemaker is set up. Nowadays, with modern medicine, we use internal pacemakers. In the past, they had external pacemakers where the wires would attach into the body and the person would have the pacemaker external to their body. But now, with modern medicine and more biosafe materials, we're able to insert the pacemaker inside of the person's body. So the pacemaker will be inserted, it goes above the heart, and then the two wires go into the veins, which go into the heart in order to regulate the heartbeat of the patient. So you can see sort of how it's set up in there, and then this is even smaller than this diagram shows. Pacemakers nowadays are size of like a dollar-sized coin, and it's pretty amazing what they can do. So one key component to look at is the battery. So it has a lithium-ion battery. It's designed to last 5 to 15 years. If you need to replace the battery, you replace the whole pacemaker. The typical voltage is 2.8 to 3.2 volts. The typical capacity is 0.5 to 1.2 amps per hour. The typical flow current of 7 microamps. Constraints for the battery include the size. We need a smaller size. The smaller we're able to make the pacemaker, the more comfort we're able to give the patient, the more abilities they have. The failure rate is another constraint. The battery can't fail. The battery can't be unregulated. The battery can't die unexpectedly, or there's gonna be a lot of issues. Some people have to rely on their pacemaker to be able to live. The next aspect is the lifespan. The longer we can make the lifespan of a pacemaker, the longer the pacemaker can stay in the patient and the less procedures that need to be done. And then last is the biocompatibility. The pacemaker needs to be something that can be inside a person's body and is safe for them. When pacemakers were first made, there was complications that people had when they first tried to have internal pacemakers because of the non-biocompatibility aspects. My fun fact is about Arne Larsson. He was a Swedish engineer. He was the first ever pacemaker user. He lived for 43 years after beginning use of his pacemaker. His pacemaker was externally located with wires attached to the veins, and he had 26 different pacemakers due to battery changes during his lifetime. Thank you for coming to my presentation.